Welcome. This second video is going to look at the paper 2 or free response questions from the chapter 7 equilibrium quiz. So question 9 shows you that in a carbonated drink you have CO2 in an aqueous solution or dissolved in your drink, and under high pressure there's an equilibrium with that small amount of air on the top of the can where there's some CO2 gas also in that air pocket. So it says, describe the effect of opening a carbonated drink container and outline how this equilibrium is affected. And what a lot of you mentioned was that CO2 escapes, which is true. Really, you should have mentioned the decrease in pressure, which is what relieves the crowding on the product side. But either way, since the gas is only on the product side, only the product side gets the relief of this decrease in pressure. So the shift is going to be for the equilibrium to move to the right, or for more CO2 to leave the soda to replace that lost gas, and that's when your soda flattens. So now you know the equilibrium and the chemistry behind your soda going flatter. On number 10, we've got an equation there. Cl2 plus SO2 forms SO2Cl2, and we see it's exothermic. It's taking place at 375 degrees in a 1 liter closed container. So deduce the equilibrium expression, constant expression. This is pretty straightforward. Put the product on top, there's no exponent. Multiply the two reactants on the bottom, and you have your expression. Number 2 says if the temperature of the reaction is changed to 300 degrees, so this is a decrease in temperature, stating a reason in each case whether the equilibrium constant and the value of Kc will increase or decrease. So this is worth 3 marks, one for stating if equilibrium concentration increases or decreases of the product and what the effect on Kc is, and then giving a reason. So the temperature decrease is going to cause an increase in the concentration of the product because it's exothermic. So decreased temperature favors the product or acts as if you've removed a product. And then when you increase the product, you can expect to see an increase in Kc when it's the result of temperature change. Part 3 of this is the volume of the container changed to 1.5 decimeters cubed. Predict stating a reason in each case how this will affect your concentration of product and the value of Kc. Well, the volume has changed from 1 to 1.5, so that's an increase in volume, which means a decrease in pressure. And a decrease in pressure, a change in pressure, is always going to have a greater effect on the more crowded side. And in this case, the reactant side is more crowded. So the reactant side is going to see the greater decrease in collisions, which means products are now going to have the greater number of collisions. Instead of being equal, products are going to have a greater number of collisions, and some of that product is going to become reactant. So the concentration of SO2Cl2 will decrease as the equilibrium shifts to the left. Kc is going to remain the same, however. And then 4, suggest stating a reason how the addition of a catalyst at a constant pressure and temperature will affect the equilibrium concentration of SO2 and SO2Cl2. So this one they're only asking about the equilibrium concentration or the yield, and it's from a catalyst, so most of you knew there'd be no effect. It only affects the rate. And the reason why, you have to either tell because you're lowering the activation energy or because you're affecting the forward and reverse reactions equally. Number 11, we've got the equation there for producing methanol. So state the equilibrium constant. Again, pretty straightforward. It's your concentration of methanol over your concentration of carbon monoxide times the concentration of hydrogen squared. State and explain the effect of changing the following conditions. Increasing temperature at a constant pressure. Well, since this is exothermic, it will be like adding product. So the equilibrium, the methanol is going to decrease. There's going to be less methanol produced, and the equilibrium is going to be shifting to the left, and we'll see less methanol present. Increasing the pressure of the reaction at constant temperature. Since the reactant side is more crowded at 3 moles, we will see more product forming as the collisions increase more on the reactant side. So that would be an increase in the methanol concentration. C says the conditions used in industry during the production of methanol are a temperature of 450 degrees and a pressure of up to 220 atmosphere. Explain why these conditions are used rather than those that could give an even greater amount of methanol. So for the 2 marks, you were supposed to address the temperature, that the temperature is being used to keep the rate faster without totally sacrificing yield. So it's kind of a moderate temperature. And the 220 atmospheres is expensive to run, but it's enough pressure to give a pretty good yield without driving the expense real high, instead of going even higher than that. So 450 degrees is somewhat high for the temperature, but that's to help keep the rate going. And the 220 atmospheres isn't the greatest pressure you could use. More pressure would help it even more, but then it gets very expensive and you get safety issues. And then D, they talk about a catalyst. We really don't care what the catalyst is. What they want to know is what's the function of the catalyst. It's to improve the reaction rate in spite of the higher temperature that you're using, over on the back on question C. So it's to help improve the reaction rate. Actually, I should say in spite of the lower temperature used, because the lower temperature, 450, is considered kind of a moderate temperature, and a higher temperature would drive that rate up even higher. Number 12, they talk about the Haber process, and the equation is given there. And then the graph here with percentage of NH3, that's our product, against temperature. You can see as temperature goes up, the product definitely goes down. So it says use the graph to deduce whether the forward reaction is exothermic or endothermic. If an increase in temperature causes a decrease in product, it's definitely exothermic. 2, state and explain the effect of increase in the pressure on the yield of ammonia. Well, since the product side only has 2 moles, but the reactant side has 4 moles of gas, an increase in pressure will definitely favor the yield. It definitely favors the product. And part 3, explain the effect of increase in the temperature on the rate of reaction. Temperature will decrease the rate of the reaction. Well, it will increase the rate of the reaction. I'm sorry, it would decrease the yield. But increasing temperature always increases rate because there's more collisions on both sides, and more collisions that have the necessary energy, that activation energy. Number 13 was bonus material. This is pretty typical of what paper 2 questions look like. They don't concentrate on just one area. They expect you to be able to incorporate material from all the chapters that you learned. So identify the organic functional group. Even though we haven't gotten to this yet, if you look at vegetable oil and biodiesel, the thing they have in common is this OCO group, which is known as an ester. So if you just came up with the structural formula for it, that was enough for me to give you a mark. And then down below they give you some data, the raw data of the oil, methanol, sodium hydroxide, and biodiesel produced. And it says the relative molecular mass of the oil used by the student is 885.6 grams per mole. So calculate the amount in moles of the oil and the methanol. So I started with 1,013 grams of that oil, and if I divide by its molar mass, I get 1.14 moles of oil. The methanol, I know, is CH3OH, so its molar mass is 32.05. So 200 grams of methanol is going to be 6.24 moles. And then they also want to know the excess methanol. Well, since I use methanol in a 3-to-1 ratio, go ahead and multiply 3 times the 1.14 moles of oil, which is my limited reactant. And I see that would use 3.42 moles of the methanol. And when I subtract that from the 6.24 moles that I started with, I have 2.82 moles of methanol in excess. C, the reversible arrows in the equation indicate the production of biodiesel is an equilibrium process. What's meant by dynamic equilibrium means that the forward and reverse reactions continue at equal rates. And using the abbreviations vegetable oil, methanol, glycerol, biodiesel, deduce the equilibrium constant. So that was pretty easy. It's going to be your concentration of glycerol times biodiesel cubed over vegetable oil times methanol cubed. Suggest a reason why excess methanol is used in this process. It's to keep the yield high, to drive the equilibrium to the right and keep the equilibrium moving to the right, to keep that product, to keep cranking out. And number 4, state and explain the effect that the addition of the sodium hydroxide catalyst will have on the position of the equilibrium. Again, this is 2 marks, so you need to explain it. There's no effect because it'll only increase the rate by decreasing activation energy, or by affecting both forward and reverse reactions equally. And then D, reactants had to be stirred vigorously because they form 2 distinct layers. Explain why they form 2 layers and why stirring increases the rate of the reaction. The 2 distinct layers is because they're not soluble in each other. One is polar and one is nonpolar. Methanol being polar with those OH groups, and oil being nonpolar. So there's little attraction or little solubility of these 2. And then the stirring will increase the frequency of collisions between these 2 layers. E, calculate the percentage yield of biodiesel obtained in this process. Well, I'm going to have 3.42 moles yielded since it's in a 3-to-3 or 1-to-1 ratio with methanol, and I know I'm using 3.42 moles of methanol. And then you need to know biodiesel's formula here, which is C19H36O2, and that would give you a molar mass of 296.55. And when I multiply that by the 3.42, my theoretical yield would be 1,014 grams. So then when I divide my actual yield by the theoretical, I come up with an 80% yield, which is really high. And F, when biodiesel is combusted, it produces carbon dioxide. Explain why the use of biodiesel as a fuel does not significantly contribute to global warming. This is the same reason why burning a fire in your backyard, burning, wood really doesn't contribute to global warming, because both sources come from plants that absorbed or use CO2. Remember, the whole photosynthesis thing is CO2 being combined. So it's completing the cycle. If that tree had died in the forest and broken down, or that plant had died wherever it was growing and decomposed, it would have released that same CO2.